So the plan here today is to give you an introduction to what to look for and which considerations to be made when systems have to be upgraded from the, let's say, the older 2G and 3G technologies to the more modern cellular technologies in the market. So I will come through that, give you an introduction to what considerations you need to do and look into. But to start off with a few words about SIMCom for those who do not know it. It's a Chinese origin. It's more than 20 years working with cellular technology. We have a long experience, working from, yes, 2G and 3G technologies, 4G in particular, also now 5G in different aspects. And that's, you can see the core competence of what we're doing. We do a lot of course, certifications and carrier support, and I'll come back to that in more details later. We still have all our design activities taking place in China in different locations. So we spend a lot of energy, money, and time on designing modules based on existing chipsets. Again, I will talk to that in a minute. So again, we have a long experience in this industry. This is our core competence. This is what we're doing. It is our bread and butter of let's say, of this one. So cellular connectivity is actually something we are really strong in. Just to give you an idea about our capabilities, because of course, making modules like us also requires a lot of technical test equipment to make sure. And just to show you here and illustrate that we just recently, actually mid last year, moved into new facilities in Shanghai, where we have a lot of new test room facilities, both from the RF side, but also from audio test side and even GNSS receiver side. So we have a lot of test equipment available now to do tests to make our systems even more reliable. And on the lower left-hand side, not that I'm going to spend much time on it, you can see a lot of 5G activities. And that's because we have invested heavily on equipment for 5G, but that will be for a later webinar, I hope. Something we also pay a lot of attention to is that once customers are designing with our modules, we very much want to be involved in the whole design process, the support together with our local distributors, like Ineltek, to ensure that you get first-hand technical support when challenges or issues arise with the modules of SIMCom you are working with. So just to make aware that we are, let's say, very close when it comes to technical support for designing activities, and the response time from the FA team, both locally in Europe as well as in Asia and China, are actually very, very fast. Just to give you an idea about what we actually do. In essence, what we do, we take the chipsets from known vendors like the ones you see on the left-hand side, Qualcomm, MediaTek, and ASR. As of today, earlier it was Intel, and even before Analog Device and ST, when they were dealing in that space. But today it's mostly Qualcomm and MediaTek and ASR on which our modules are based. Clearly, Qualcomm is our core chipset vendor. That is the one we use in most modules today. And that is also a company where we have a relationship with for 16, 17 years. So I think we have a strong relationship with Qualcomm. Same goes with MediaTek. MediaTek is on the lower end scale of the cellular connectivity. We also have a long relationship there. But this picture also shows that being a module vendor, we need to engage with a lot of different companies. On the top hand side, you see the cloud connectivity solutions, mean that we have capabilities of cloud certificates in the module. Of course, that needs to be certified, verified by the cloud providers. On the bottom side, also some other, you can say, connectivity providers that we are dealing with, and lots more of those have come later on. And on the right-hand side, a lot of the MNOs, the mobile network operators, that we need to work with Ineltek to ensure that our modules are working on their network. Some of these MNOs are more strict than others, especially the ones in North America, you may know, like AT&T and Verizon. They have a long, you can say, certification process, and we tend to, let's say, take all the modules that can work in North America to take through that certification process. It takes time, so and it's quite costly, but that is a given. That's something we need to do to ensure our modules are working on a global scale. So basically, besides those certifications, we of course also need to provide the normal regulatory certifications like CE and FCC and the rest of it, which we of course also perform. So all our modules have been through all the regulatory certifications. So that is, comes with that one in mind, making the end application somehow easier to get certified at the end of the day. Depends, of course, mostly on the antenna design, but that's another thing. One thing I just show briefly on the supply chain, not that this is going to be commercial, but in these days where lead times are critical, we are, as the only module vendor, having own production facilities. And right now we are still managing our production and our capabilities quite nicely. So on most devices, except old 2G, but on most devices today, we have between 8 and 12 weeks lead time. So that we still maintain to do, and that's because we're good material planning, and we have, let's say, well control on our production sites, which, by the way, is in 5 different locations, where one of them are within EMS called BYD, very known Chinese company that basically are also producing modules for us for the automotive industry. So just to go through what happens in the cellular community, and this is where things actually goes to this topic here. In the old days, there was 2D and 3D modules. All these modules came as a consequence of cellular mobile phones. When the cellular industry saw, well, using those cellular mobile phone technologies into the so-called M2M communication at that time, well, that was a nice way to do the communication. Now everyone knows that has expanded dramatically since then. IoT was invented, low power IoT was acquired, and which actually 2D and 3D did not really allow. But that was based on this, that the standardization organization 3GPP started to develop the low power solutions like NB-IoT and Cat-M. At the same time, the whole standard LTE industry was mainly driven again by cell phone and the content that we need on our cell phone. That drove up the speed to Cat 6, Cat 9, Cat 16, and now even 5G to give the very high speed. We also know the 5G technologies is quite expensive, while at the other end of the scale, the NB-IoT and Cat-M is the low end and the low complexity and also low cost. So everything has expanded in all directions when it comes to cellular technology, which also means that when selecting cellular technology today has been much more complicated than just, say 10 years ago, where there was 2D and 3D. Where are the status of 2D and 3D network as of today? This is just a snapshot of where things are. And mainly in Europe, in the middle, I guess most of you are aware of, 3G has been switched off by many places. 2G will still live because there's a lot of 2D based devices out there. Now we also know that none of the current mobile network operators are investing in 2D anymore. And in fact, there's a couple of frequencies that has been removed from the 2D network, now meaning that we start to see congestion or bottlenecks on base station level on 2D devices. Everything's because they need to move on to the 4D technology, either by NB-IoT, Cat-M, or even later on the 5G technology. So here you can see how things apply in North America, Latin America, and Asia Pacific and Africa besides here, but the same message is more or less the same. 3G is being cut off and 2G will live for another 3, 4, 5 years maximum, but there will be limitations in terms of upgrade, of maintenance, and sometimes also congestion on the base station level, meaning that consideration needs to be done. Another important thing is that adding to this and also giving us the guidance, something that you can say, when we had 2D and 3D, we were very much following the industry of mobile phones. With the introduction of NB-IoT and Cat-M, there are no such things as mobile phones for that. So we had to see where the market industry goes. And since then, we now can see that even LTE Cat 1 and the other solutions are becoming more and more dedicated to the IoT space, moving away from the cellular communication, being low-cost data communication, very much driven by the need for connected devices of everything. So basically, you can see here, this is a research, an investigation done by API Research, that some of the dominating technologies for the future will be LTE Cat 1 or LTE standard and NB-IoT. NB-IoT mostly because it's China. In China, there is a lot of NB-IoT rollouts, not so much in Europe, but very much in China. But what we see now in Europe, that the LTE Cat 1 and Cat 1 bis is actually taking off as a supplement to Cat M and NB-IoT. And there's a reason for it. I'll come back to that. So right now we can see, if you take at the snapshot of the modules that we're doing today, all the way from the left-hand side, the GNSS receivers, I don't want to spend time on that, the 2G and the 3G, which portfolio is becoming less and less because the chipset vendors are pulling out. We're not, let's say, investing any news in the 2G and 3G, so everything is going on to LTE or LPWA, like the NB-IoT Cat M, and even LTE Advanced and further up, not subject for today's discussion. So right now is the industry, like SIMCom and others, working on how can we close the gap, close the loop, you can say, by once the 3D and 2D are being removed. Now we know that NB-IoT Cat M has been a part of the answer, but we also know it's not the full answer, because even Cat M, NB has some limitation when it comes to coverage, especially outside Europe. And let's say in African continent or in some Asian continent, Cat M is not there, and even in African continent, NB-IoT is not there. But when you look in a global perspective, standard LTE Cat 1 are basically present everywhere where there are cellular network coverage, which actually gives, let's say, the opportunity to create, let's say, global devices. And one of the things you also will learn during this presentation is that we're still working with compromises. We're not there yet where we can say we have a true global covering device like we had the 3G and 2G yet. But the industry is going that direction. It will come eventually, but we're not there yet from anyone. So basically, just as I said, from the old days, the 3G and 2G was fairly trivial, if you can say so, onto the different kind of LTE technologies as of today. NB-IoT, LTE-M, or Cat M as it's called, standard LTE, LTE Advanced, even 5G, and move on. If you look at the modules that we are doing on the LPWA stuff first, there you can see, well, we have a number of low power wide area modules that basically supports both Cat M and NB-IoT. And that is the devices that, you know, can be deployed. They've been around for quite some time, and a lot of applications are out there using Cat M and NB-IoT. Now, that roadmap here is mostly driven, at least on the upper side, by Qualcomm. It's a popular device, different versions for having, let's say, LTE-M/NB, and even for the large part, a 2D fallback capability. On the lower hand side, we have NB-IoT only, and NB-IoT only is a very simple, you know, cellular connectivity where the cost is a key, power consumption is key, and those elements are very, very key. If you look at the LTE roadmap, we take this first before I go into the next one, which I think is even more important, is that we take the LTE standard. We have historically been working very much with Qualcomm's chipset. They are very well proven. They are working very nicely. They are robust. They are certified globally, etc. But they are also quite costly. So what we have seen is that ASR, which is an ex-Marvell spin-off, or let's say Marvell sold it to a Chinese company a couple of years ago. They have just, this company ASR have finalized the chipset and generated a number of, you can say, more IoT-friendly standard LTE Cat 1 devices, smaller size, lower cost, and more, let's say, IoT-friendly capabilities like Bluetooth, low energy, and even, let's say, Wi-Fi scan capabilities, if needed, introduced into the chipset at a different price. Now that allows, let's say, a whole new area of applications moving onto LTE Cat 1. If I take the low-cost LTE Cat 1, which is besides the NB-IoT and Cat M, the low-cost LTE Cat 1 is where we see a big part of the business will transition from 2G and 3G, because we now start to see the chipset vendors are coming out with solutions which are much more IoT friendly than in the past, and even Qualcomm are. So if you see here what's happening, that we have actually today introduced a number of low-cost ASR-based modules for LTE Cat 1 operation. And that the downside with these are they are only regional. So you can say we have one for Europe, one for South America, and one for Asia, but we have none for North America. And that is the reason for political that North America does not want to approve Chinese architecture chipsets. We know that that is a given. That is how it is right now. But we also know that Qualcomm are pushing very hard to bring out a low-cost LTE Cat 1 solution for this space here of the IoT. And they are coming out later this year with a chipset which allows us to also generate a low-cost LTE Cat 1 solution for the North American market. Now, commonly here, which is not very clear, and that is one thing that you may, if you have been working in the cellular industry, is that standard LTE Cat 1 are actually requiring 2 antennas in the design. And a normal and standard antenna and what they call antenna diversity. Now, this complicates designs. It makes design more costly. But you know, with the introduction of LTE Cat 1 BIS, which was ratified some years back, the BIS standard actually allows for only 1 antenna. So all these modules you see here in the screen right now actually support LTE Cat 1 BIS, meaning that you can create a standard solution with only 1 antenna, not adding to the cost. Adding to the things which does not stay here is that even the LTE Cat 1 BIS standard also now have introduced eDRX, which helps for the power consumption, as well as power save mode, also helping the power consumption. So the whole LTE Cat 1 space are also now moving towards, you can say, low power wide area operation, where we have today the Cat M and NB. So just for a brief, for the I see time is running, that we have also in Europe in particular, we know that 450 megahertz are becoming more and more popular, both on LTE-M, but also LTE Cat 1. And we have a number of modules also supporting 450 megahertz. I know that is mostly for the metering industry, but still an technology or solution which has some clear advantages. It has much better penetration capabilities because it's 450 megahertz, the wavelength, but also the output power of the transmitter is having a much higher output power level than normal cellular communication, meaning that the 450 megahertz actually having very good coverage, you know, in basements, in areas where there is, let's say, very challenging radio frequencies opportunities. LTE Advanced, to give you a quick on that one, we are having a number of LTE Advanced modules, basically which an LTE Advanced is multi-carrier for the ones that need higher throughput. 5G modules, I will not spend much time on it, other than we have a series of 5G modules as well, second generations coming out. But what is worth paying attention to, which you may have noticed in one of the first slides I showed, is that even the NB-IoT and Cat-M radios, which today are the 4G or the LTE standard kind of radio interface, are now being worked on being the so-called new radio, allowing the NB-IoT Cat-M be so-called new radio ready. Now that is a little bit in the future, but that is the direction it's going. So all these devices will also work on the so-called 5G new radio standards. Smart modules, we have a couple of smart modules just to tell you that everything is included. It's a Qualcomm Snapdragon device, which basically has a host processor built in, a memory and display and controllers of different kind, and it's typically Android operating system that is running on these devices here. GNSS receivers, just to give you an idea, we have standard PVT, precision velocity time receivers, and that's just to show that that is here. Now, one thing I did not touch on, and that's something that is becoming more and more important, as you also know that when you're deploying IoT devices, there will be always the need for a SIM card. As there was with 2G and 3G, there's also need a SIM card when you talk to any new cellular communication. Now, when making small, cost-efficient devices, basically you don't want to touch once they've been produced, well, the challenge has been that every now and then you need to get hold of the device, plug in a plastic SIM card, close it again, and deploy it. All this adds to the cost. So the industry have developed the so-called eSIM or EUICC interface, which is an interface that allows for several SIM profiles. Now all our modules, actually, just to be clear, are supporting eSIM and also EUICC. But with all this comes also services. So there's a lot of companies that are offering services for connectivity, like remote provisioning, meaning that when you have built a device in the production line with an eSIM, you don't need to touch it. You can go out to the field being deployed, and remotely you can activate the SIM profile in there. So you don't need to have someone out there and plug and unplug a SIM card. It can be done remotely by software. So that is a huge step in the right direction. And we are not there yet where things are ideal, but they are definitely working very, very nicely. And just to illustrate that some of the companies that are working here is the ones mentioned here, and there are many more. Actually, on Embedded World that we are demonstrating here next week, we will do a demo together with Ericsson with their IoT connection platform, where they will have a SIMCom device where they have where they can provision it remotely with their IoT platform. So that's an example of there are platforms, tools available now that actually can support these elements, which is a huge value add compared to the old days where you need to have a plastic SIM card. Just briefly as a wrap up, for all the modules you've seen, we have evaluation tools that comes typically with two boards, baseband platform with a connection plus the SIM card, standard SIM card, and then another daughter board on top, which can be shifted out from one to the other, which is a nice way, easy, cheap way. And I know even that Ineltek have a lot of those in stock already, so that can be, let's say, acquired from them. And there's an easy way to get started. As I said, we have also application support that will make you started on this one. If there is any challenges, we can support you very quickly to get things moving. So this was basically the final word from my side.